Welcome to edupedia Friends, in today's video we will learn about dispersion of light and reflection of light. In the previous video we learned what is light and how light gets reflected, what is the incident ray, and how after reflection the reflected ray is formed, right? So in this video we will learn about dispersion and reflection of light. So now, to understand dispersion of light, first we need to know what is a prism. A prism is a structure which is made up of glass. So you can see here a prism has three sides and all these three sides are made up of glass, right? The three sides are actually connected together and this forms a prism. It is made up of glass. And prism can be of different shapes and size. So here we have a prism like an upright pyramid, right? So we can have different shapes and sizes of prism, and the prism is not hollow from inside, but it is a solid structure. Now, to understand dispersion of light, first of all we need to pass light through this prism. Now when I say light, what is light? Light is nothing but sunlight. And when we see sunlight, we think that sunlight is white in color or yellowish in color, but it is not true. So that we are going to confirm after we carry out this experiment. So let's first pass the light through this prism. So again we have taken a glass prism over here, and this is a window shade, and let's say if we make a hole in that window shade and we pass the light through this prism. Now on the other hand, if we again place a screen, a white screen, what do we see here? We will see so many colors which will be formed on the screen, right? And the colors will be ranging from like red, yellow, green, blue, violet, and like that. These will be the colors which are formed on the screen. This is a normal light, the sunlight which is coming. After it passes through the prism, then a spectrum of color is formed on the other side on the screen. So this is actually what we call a visible spectrum of light, right? So light is not what we see whitish or yellowish in color, but light consists of all these colors. Light consists of such a spectrum. So why do we see so many colors only after the light passes through this prism? Is because light undergoes dispersion. Light is dispersed. What is dispersion? White light is separated into its components. It has so many components. It has these 7 components. So, and it is dispersed into its 7 components. The separation of this visible light into its different color is known as dispersion. So this is what is called as dispersion. Why do we see so many colors here? Is because when visible light passes through a prism, then all these colors, the red color, yellow color, orange color, green, blue, and indigo, they all have different wavelengths and different frequencies, and because they have different wavelengths and frequency, they are dispersed through a different angle. Each color of light is dispersed through a different angle, and that's why first the yellow will be dispersed through a smaller angle, then the orange will be dispersed through slightly larger angle. So that's why this, what you see here, is dispersion angle. This is a deviation of the yellow light. Yellow light is deviated more as compared to the deviation in the red light, right? And which is the light which is dispersed the largest is the indigo light. So indigo light is actually deviated through a larger angle as compared to rest of the colors. And that's why we see such kind of spectrum on the other side of the screen. And as I said, it has different wavelengths. The maximum wavelength is of red color, which is 700 to 780 nanometer, and violet has the least, which is around 400 nanometers, right? Blue is about 500, orange is about 600. So this is the spectra of light that we will see. So now by this experiment we can confirm that light first of all is not white or yellowish in color, but it consists of 7 colors. Secondly, light undergoes dispersion. Light can be dispersed. Now tell me, where all have we seen the dispersion of light? Dispersion of light can be seen, when we see a rainbow. How do we see the rainbow? Rainbow doesn't come on a normal sunny day, but there has to be sun available and there has to be rain available. It is in those conditions that we will see a rainbow. Now, and how do we see a rainbow? In this case, what we have learned is the prism acts as a medium for dispersion of light. When the light passes through the prism, then the dispersion takes place. But in a case of a rainbow, what acts as a prism? What is a medium through which it will be dispersed? The medium is nothing but the raindrop. The sunlight, after passing through raindrop, it gets dispersed, and that's how we see 7 colors. So have a look over here. The sunlight comes and then it enters the raindrop. It gets dispersed. The violet disperses like this and the red disperses like this. And why do I say that? Because if we take a normal, see the black line that I've shown here is the normal to the surface of this raindrop at this point. So let's say if we draw a normal, this normal is at this point where the sunlight is in contact with the water droplet. So at this point, if we draw a normal, then the red light, as we learnt earlier, that is deviated with a smaller angle as compared to the indigo light. And that's why after reflection, it again goes to the other side of the water droplet and again they are reflected, and then after it comes out, this is how they are dispersed. So water droplet actually acts as a prism in this case, and that's how the dispersion of white light takes place. And what we see on the other side is a spectrum of light, as a spectrum of those colors that we see in the sky, right? So this is the example of dispersion of light. So light undergoes dispersion. Again, we see if we are here and there are so many rain droplets. So see, from here the red color will be reflected, from some other droplet blue color will be reflected, and likewise when the rain takes place there are so many water droplets, and that's how from each water droplets that light will be dispersed. And the dispersed light, what we see is in a form of a rainbow, and that's how we see these 7 colors. Now let's learn about reflection of light. These are various properties of light that we are learning. In the previous video we learned basic properties of light, like light travels in a straight line, that light can travel in all the directions, and light travels faster. So those were the basic properties of light. Now in this session we are moving on to some of the higher properties of light. For example, light can get dispersed, light can get reflected, and how it gets reflected is what we are going to learn next. What we learned in the previous video is how are we able to see the object, right? When the light flashes on a particular object, then this is the incoming light ray, and then the light is reflected from that object and it reaches the eyes of the other person or even the same person from where the light source is coming, and that's how we will be able to see this object on which the light is flashing, primarily because every object reflects light. Now, what happens in the case of a mirror? Mirror reflects light, and that's why we are able to see ourselves, or we are able to see the other person who is standing next to us in front of a mirror. That means mirrors also must be reflecting light. What is the other point regarding mirrors is that mirrors do not allow any light to pass through them. Because mirrors do not allow the light to pass on to the other side, that's why the mirrors, they are reflecting all the light, and that's why we are able to see ourselves in the mirror. That means they reflect light. If we keep any object in front of the mirror, or if we stand ourselves in front of the mirror, we are able to see our own image in front of the mirror, right? That is because mirrors reflect the light. Now, in the same example that we have learned, the incoming ray actually becomes the incident ray and the outgoing ray becomes a reflected ray. And that's why we have 2 kinds of rays, right? Now, On any reflecting surface, let's say we have a reflecting surface, and if we have an incident ray, then we will have a reflected ray also. The angle, let's say this perpendicular line to the reflecting surface is what is known as the normal to the surface, right? Now, with this diagram, we will move on to explaining and discussing the laws of reflection. What are the various laws of reflection? Now, let's consider that we have a plane mirror and we have this incident ray which is coming and striking the plane mirror. We also know that mirrors do not allow any light to pass through them. So what happens? All the light is reflected. So this becomes the reflected ray. And this is what we call a normal. Now the first law of reflection is that the incident ray, the reflected ray, and the normal to the reflection surface. This is a reflection surface. So what is normal to the reflection surface is this red line. Now these three, the incident ray, the reflected ray, and the normal to the reflection surface at the point of incident. This is the point of incident. This point is the point of incidence. They should lie in the same plane, right? It is only after that the laws of reflections will satisfy. So that is the first thing. Next thing is that if they all lie in the same plane, then the angle of incidence, which is the angle made by the incident ray and the normal, is known as the angle of incidence, and this we reflected by writing a small I. So this is what this is a small I, right? This is the small I angle. So this angle of incidence will be equal to angle of reflection. What is angle of reflection? Angle of reflection is the angle that is made between the reflected ray and the normal is the angle of reflection. So both the angles will be equal. Angle of incidence will be equal to angle of reflection. So these are the laws of reflection. Now the laws of reflection actually satisfy everywhere. Whether it is water, whether it is a glass, whether it is mirrors, anywhere. The laws of reflection, they are in nature, are always complied to. Let's say this is the water. You see the reflection in the water, that is again because of laws of reflection. This is a small lake, so we will be able to see reflection of the trees which are just by the side of the lake. Now this reflection is also because of laws of reflection. So laws of reflection are maintained everywhere. They are satisfied everywhere. Light will always follow laws of reflection. Whether it is a smooth surface or it is a very, very rough surface or it is water, anywhere. Now, let's see whether we will be able to solve this numerical or not. This numerical is based on the laws of reflection only. If we have a light incident on a flat surface, making an angle of 10 degrees with that surface, as shown in the figure, this is the figure. So we have a incident ray and it is making an angle of 10 degrees. So 10 degrees is this angle which is below this red line, right? This is actually the reflecting surface, what you see here. Now, what is the angle of incidence, first of all? And secondly, what is the angle of reflection? Also, sketch the path of the reflected beam on the diagram. So, we know that light is incident on this surface and it makes an angle of 10 degrees. So, what is the angle of incidence? If the light makes an angle of 10 degrees, that means, see, we know that this is a normal. So what is the angle between this normal and this reflecting surface? It has to be 90 because normal is always perpendicular to the reflecting surface. Now, if the incident ray is coming at an angle of 10 degrees with the surface, then 90 minus 10 will be 80. So the angle of incidence will be 80. Right? So that is the answer to the first part of the question. That is, the angle of incidence is 80 degrees. Now let's move on to the second. As per the law of reflection, the angle of incidence has to be equal to the angle of reflection. So if the angle of incidence is 80, then the angle of reflection also has to be 80. And the path of the light will be as shown. The light will come like this and it will move out with the same angle of reflection. Now, We talked about reflection of light. Let's see what happens when we have a rough surface. In all the previous cases, what we've just learned, we always said that the reflecting surface is a smooth surface. So let's say if the parallel rays are incident on the smooth surface, then the reflected rays which are going out will also be parallel to each other. That is because this is a smooth surface. But what happens in the case of a rough surface? If we have an incident, a beam of rays which are coming, then will the same beam be reflected outside? So if we have parallel rays which are coming, will the reflected rays will be parallel? No. That is because the surface is a smooth surface. But now the question is that as per the laws of reflection, we know that angle of incidence has to be equal to angle of reflection. But in this case, what is happening? The angle of reflection, the angle of incidence is not same as the angle of reflection. So what happened? Are the laws of reflection satisfied over here? Yes, they are satisfied. I'll tell you how. This is the incident ray and this is the reflected ray. Now let's say if I draw a normal at this point on the surface, I don't have to think about the entire surface, but let's see at this point. So at this point on the surface, I draw a normal. So the normal will be like this. Then the incident ray and the reflected ray, both these rays will form an equal angle with the normal, right? So this angle, that is the angle of incidence, and the angle of reflection will always be same with respect to this normal. Let's take this incident ray, right? The second incident ray. Again, what happens at this point where it is getting incident on that surface, I have to again draw a normal. So now a normal will be like this as shown here. So this angle, that is the angle between the incident ray and the normal, this angle will be very, very small. This angle will be equal to the angle between the normal and this reflected. Again, you can see there is hardly any angle. The angle is very, very less, right? So they will be equal. Again, this reflected ray is again incident on this point on the surface. So now this becomes a incident ray. Again, if I draw a normal at this point on the surface, then the angle of incidence, that is between this incident ray and this normal, will be equal to the angle of reflection, that is this reflected ray and the normal. So this angle is the angle of reflection and this is the angle of incidence. So they both will be equal. So on a rough surface, how do we check out whether the laws of reflection are satisfied or not? Is by drawing small normals on every point of contact wherever the ray is incident. But the laws of reflection are always satisfied. Now we move on to discussing what is regular reflection and what is diffused reflection. Regular reflection is, for example, if we take a plane mirror, then if we have the incident rays which are parallel to each other, if they are incident on the plane mirror, then the reflected rays will always be parallel to each other because it's a regular reflection. However, what is a diffused reflection? Diffused reflection happens only on a rough surface wherein the incident ray, if let's say we have a beam of rays or parallel rays which are incident on this surface, then the reflected ray won't be parallel to each other. So it's not a regular reflection, but it's a diffused reflection. Reflection will be there, laws of reflection will be satisfied, but the kind of image that we will be receiving on the other side will not be a clear image, clean image, but it will be a diffused image because the reflected rays are not coming out in an evenly fashion. So that is why we call such a reflection as a diffuse reflection. Right. So example of regular reflection will be mirrors. However, example of diffuse reflection will be the kind of reflection that I had shown to you in the water or in the lake when we see the reflection of the trees or when we see the reflection of any person who's walking in the water. So he will be able to see his own image. So those kinds of reflection or the image that you see will be diffused image and diffused reflection, right? I'll give you one more example. Let's say you have a lake and the lake is very, very calm. The water is not moving, so you will be able to see a better picture, a better image. However, if you just drop a stone in the lake or just disturb the water with your hand, then that image that you see will be a diffused image, right? So in this video, we learnt about dispersion of light and reflection of light. Now that we know how the diffused and regular images are formed, so in the next video, we will talk about how exactly and in detail the image by plane mirrors are formed. So thank you for watching Edupedia World videos.